The topic is a span of vectors. If we have, say, for example, some vectors u1, u2, and then so on up to um in Rn, which means that each of these u vector is of dimension n. That means each u1 has n components. Okay, so then the set of all possible linear combinations x1 u1 plus x2 u2 can be represented like this, plus xm um. So where x1, x2 and xm are real numbers, this linear combination will be called as the span of the set. Okay, so it will be the span of this Rn. Rn is the set of such vectors. Okay, so and it is denoted as something like this: span u1, u2, and then up to um. So basically this is a concept, and then this concept can be used for determining whether some of the vectors are independent from each other or not. So I will illustrate it with the help of some examples. Okay, so starting from example number 1. Okay, let's see, we have a vector u1 is 1, 2, and vector u2 as -1, -3, and vector b as 4, -2. So we have to determine that whether or not the given vector b is in the span of the vectors u1 and u2. So if we want to determine the span of u1 and u2, so then we can do is we can multiply u1 and u2 with some constants, like in this case x1 and x2, and we can determine the values of this constant to give the value of v. So then u1 and u2 will be in the span of b. Okay, by the definition. So it is simply actually that becomes the case of finding the solution of the system of linear equations. So suppose those scalars are with which we can multiply u1 and u2 are x1 and x2. So x1 u1 plus x2 u2 is equal to b. So in order for b to be in the span of u1 and u2, then x1 u1 plus x2 u2 should be equal to b. So in this case x1 and then u1 is 1, 2 plus x2, and then u2 will be -1, -3, and this will be equal to b, which is 4, -2. So this will convert into the system of equations. So for example, x1 minus x2 is equal to 4, and then 2x1 minus 3x2 is equal to -2. So this is a system of two equations, so we can solve these two equations. And then, so for the solution of this, what we can do is we can multiply this first equation, or we can apply the Gauss-Jordan Gauss elimination method, whatever method you want. But maybe simply in this case, maybe I can multiply this first equation by -2. Okay, so it will be -2x1 plus 2x2 is equal to -8, and then it will be 2x1 minus 3x2 is equal to -2. And then we add these two equations, so x1 term will cancel, so it will be -x2 is equal to -10. So x2 will be equal to 10. and from here we can find the value of x1, because we know that from this x1 minus x2, so x2 is 10, so is equal to 4, so x1 is equal to 14. So we get some values of x1 and x2. So it means that we can say that, for example, now, because by taking the value of x1 is equal to 14 and x2 is equal to 10, we can say that these vectors are these vector u1 and u2 are in the span of vector b. This is what we wanted to determine. So our answer is yes, the given vectors u1 and u2 are in the span of vector b. Okay, so u1 and u2 are in the span of b. Okay. Let's see one more example. Same. We need, if in just in consider now, you have u1 is equal to, this vector is equal to 1 0 minus 2, 1 0 minus 2. u2 is equal to 0 to 1, and b is equal to 1 minus 4 minus 4. So whether now these are in the span of u1 and u2 are in the span of b or not. So in this case, what we can do is, so suppose if they are in the span of this, then we can write a augmented matrix. Okay, 1 minus 4 minus 4. Okay, so now we have 3 unknowns and 2 equations. Okay, yes, we have 3 equations but 2 unknowns, x1 and x2. Okay, so we can apply the Gauss elimination method. So this is 0, this we need to make it 0, so 1 0 1 0 2 minus 4, and the row operation which we will apply is 2 times row 1 plus row 3, that will be the new row 3. Okay, so that will be 0 0, and then plus, that will be 1, and then 2 minus 4 is minus 2. Okay, so now this equation is in the echelon form. Okay, because this is the leading term, and the next leading term is over here in the next column, and we can now find the solution. So for example, from the last equation, we will get this will be corresponding to x1, this will be corresponding to x2. So from the last equation we will get x2 is equal to minus 2. Okay, x2 is equal to minus 2. From the previous equation we will get 2x2 is equal to minus 4. This will also give like x2 is equal to minus 2. Okay, x2 is equal, so both equations give the same answer. And in the from the first equation we get x1 is equal to 1. So we get a unique solution, x1 x2 as 1 and minus 2. So this means that if we multiply this u1 by 1 and then multiply this by minus 2, then we will get b. So we can even just verify it. So by 1 it will be 1 0 minus 2, and then minus 2 multiplied, so so it will be plus 0, minus 4, and then it will be minus 2, so it will be then 1 minus 4 minus 4, which is same as B. So it means that U1 and U2 are also in the span of B. So we can actually write it like this: U1 and then minus 2 U2 is equal to B. Okay, because corresponding to X2 it will be minus 2. Okay, next same thing which we want to check: if U1 is 1 0 minus 2 1 0 minus 2, U2 is 0 to 1, and then B is equal to 4 minus 1 4. So whether these are in the span or not. So we can write it in the augmented matrix form: 1 0 minus 2, 0 to 1, 0 to 1, and then augmented matrix will be 4 minus 1 and then 4. So it will be, now for this 1 0, this is already 0, this we need to make 0, so we multiply first row by 1 and then add to the third row, that will be the new third row. So it will be 1 0 4 0 2 minus 1, and then it will be 0, and then it will be 1, and then it is 4. So it is in the echelon form. So from the last equation we get x2 is equal to 4. Okay, x2 is equal to 4, and in the from the previous equation we get 2x2 is equal to 2x2 is equal to minus 1. So we get two different values of x2 in this case. So there is a conflict over here. Okay, so for example x2 is equal to minus 1 by 2. So when there is a conflict between these two values, this means that the system is inconsistent over here. So we will say that B is not in the span of U1 and U2. So for any choice of the values of x1 and x2, we cannot get B in this case. So our answer is U1 and U2 are not in the span of B. Or another way of saying this is that B is not in span U1 U2. So this is another way of saying like this. So we can even verify it as well. So for example, we get, for example, one value. If we take, for example, x2 is equal to 4, and then from the first equation we get x1 is equal to 4, and and for this pair also x1 is equal to 4. So if we, for example, if we take these 4 values, so it will be 4 0 minus 8, and then this will be also 4. So 0 8 and then 4. So 0 8 and 4. So it will be 4 8 minus 4, which is not same as B. So that doesn't satisfy the values. Similarly, for the other pairs, we cannot get the value of B. So this means that our result is correct.